Okay, let's continue. In electrolysis of molten compounds, we have the electrolytic cell. Inside the electrolytic cell, the electrolyte is the ionic compound in the molten state. And we have electrodes. Those electrodes, they are made of graphite here. The reason of using graphite, reason number one, it's electrical conductor. So it can conduct electricity inside the circuit, and also it's inert, so it can conduct electricity without being changed. Okay, so electrodes here, they are made of graphite. My electrolyte, again, it's the molten ionic compound, and we will start the steps of the electrolysis for molten compounds. First of all, electrons will start to move from the negative end of the battery. We call it what? The negative end, sorry, of the battery toward the negative electrode. That negative electrode, we call it cathode. Okay, so electrons will start movement from the negative side from the battery toward the cathode. At the cathode, we have positive ions will be attracted to that cathode in order to what? To accept those electrons. Okay, so those electrons will be accepted from the positive ions in the electrolyte. Okay, then this electrical current will continue its movement through the electrolyte using my ions. So how can I move electricity through electrolyte? By the free ions. At the anode here, we have what? We have negatively charged ions. They are attracted. They are attracted in order to what? To donate electrons. Okay, so giving electrons or donating electrons, we call it what? We call it oxidation. So at anode, we have oxidation. Because of this, we call it anox. Anox. Okay? While on the cathode, we have reduction. We call it red cat. Okay? So because of these ions, we can move electricity, or we can pass my electrical current through the electrolyte, and those electrons, the donated electrons, will continue their passage through the graphite and wires to be accepted by the battery. So we have closed my circuit direction for electrons from the negative end of the battery toward the cathode. At the cathode, positive ions will be accepting those electrons in order to give them to negative ions. The negative ions will give those electrons toward the anode, and they will continue their journey through the circuit towards my positive end of the battery. Okay. We can also use other substance for to make those electrodes, which is also inert. It's platinum. So for inert electrodes, we have two choices. Either we can use graphite or platinum. Both of them, they are electrical conductors, and in the same time they are inert. Okay, let's take some examples for electrolyte. Some electrolytes we can do for them electrolysis through my electrolytic cell. It's molten lead bromide. We can see here lead bromide, it's ionic compound. It's composed from metal and non-metal. And we can see here, number 2, it's the oxidation state for my lead. Okay, let's demonstrate or represent my electrons or ions will we will have in my electrolyte. By heating or melting my lead bromide, I will have free ions from bromide ion and lead ion. Okay, bromide ion will go to its negatively charged ion, and we call it anion. This anion will be attracted to the anode. Okay, it will be attracted to the anode. At the anode, we have only what will happen at anode. Oxidation reaction takes place. So this bromide ion will lose electrons. Okay, so it will be oxidized. Okay, how can I write half ionic equation or half ionic equation for oxidation? I will start with bromide ion, Br minus. That Br minus, it will be oxidized to the other form. The other form for nonmetals, it's what? It's molecule. So all the time, the nonmetals, when they are transferred to the other form of it, it will be converted into a molecule. In order to balance that half ionic equation, I will start balancing atoms. So we have here 2 atoms, we have here 1 atom, so times 2. Now balance charges. Charge from for this molecule, it's 0 charge. Here the charge, it's 2 times -1, so it's -2. In order to make those 2 sides equal, I will add electrons to the more positive side. So I will add here 2 electrons to have -2 with -2 here. So by this I have written my half ionic equation for oxidation for bromide ions, and we can see, or we can describe the observation for that reaction by the formation of reddish brown fumes. So the bromine, it will be formed on the gaseous state and it will give me reddish brown fumes. Okay, and you have to memorize this state for my product. Let's see what will happen with the cation. This cation will be attracted to the cathode. So you can match the name of the ion with the electrode. Cation is attracted to the cathode. Why? The cathode is negatively charged and the cation is a positively charged ion. So they will be attracted to each other. At the cathode, all the time we have red cat. It means we will see reduction. So this positively charged ion will be reduced. Okay? What will be the opposite, or what will be formed from the reduction of the positive ion for metals? It will be converted into metal or neutral atom. Okay, so Pb plus 2, all the time when they are reduced, they will be converted into neutral atoms, which are Pb atoms, lead atoms. How can I balance that equation? Balance number of atoms. Here we have 1 atom, here we have also 1 atom. The charge here is plus 2. The charge here for neutral atom is 0 charge. In order to make them equal, I will add electrons to the more positive side, so I will add it to that side. By this side, it has 0 charge, and that side also it has a 0 charge. Okay, the observation of that reduction, why it's reduction, we can see here the oxidation state, it has been decreased. Okay, it decreased. From that side we have plus 2 to 0 charge, it's reduction reaction. And also we can see electrons is before the arrow. We call this reaction a reduction reaction. Okay, and the observation for that formation of lead, we can see gray metals, gray metal deposits. So it will deposit on the on my cathode. I will see deposits of lead here, okay, as a precipitate, or it will be formed under the cathode here also, or Again, the metal will deposit on the cathode or below it. So I can see a precipitate or a gray precipitate of my lead, and at the anode I will see fumes, and they are reddish brown fumes because of the production of bromine gas. That's it. Okay, let's take other example. Molten sodium chloride. Molten sodium chloride, by melting sodium chloride, I will form the free ions, positively charged sodium and negatively charged chloride. Chloride will be attracted, it's anion, so it will be attracted to the anode. Okay, at the anode, what will happen? Anox, it means oxidation. So chloride ions will be oxidized in order to form what? What is the opposite form of the negatively charged ions? They are nonmetals, so they will form what? They will form Cl2 molecule. Okay, how can I balance that equation? You start with balancing number of atoms, so I will multiply this by 2. Then you balance the charge. Here we have -2 charge, so it has this charge, this size, it has -2 charge. Here we have neutral molecule, it means we have 0 charge. So in order to make them equal, I will add electrons to the more positive side. It means I will add here 2 electrons. We can see here increase in the oxidation state. It means we are having oxidation reaction, and also the electrons are after the arrow. Okay, so also this is another proof that we have oxidation reaction. Okay, in order to say what's the observation of that reaction, I can see bubbles. We will see bubbles of green gas. Okay, so this reaction, oxidation for chloride ions, will form bubbles of green gas, and those bubbles will form at the anode. Here at the anode I will see bubbles of green gas. Okay, let's see what will happen with sodium. With sodium will be attracted, it's what? It's cation. So cation, it will be attracted to the cathode in order to be what? Red cat. Red cat, it means reduction. So this positively charged ion will be reduced. Okay, the other form of that oppositely charged ion or cation, it's neutral atom, because metals either they exist as positively charged ion or neutral atoms. Non-metals, it's opposite. Either they could exist as negatively charged ions or molecules. Okay, so reduction for positively charged ions here, it will be converted into what? Into neutral metal. How can I balance that equation? We have the same number of atoms. In order to make them equal according to charge, I will add 1 electron here in order to make that side 0 charge and that side a 0 charge. And the observation for that reaction is what? It's metal deposits also below the cathode. So all the time the formation of metal, it will be as a precipitate. Okay, as metals they are exist in the solid form. Okay, let's continue with the other case of electrolysis. If we are going to electrolyze aqueous solution, what's the meaning of aqueous solution, and what's the difference between aqueous solution and molten ionic compound? Molten ionic compound, it contains only the ions of the ionic compound, while if we are having aqueous solution, it means I have dissolved that ionic compound in water. It means I have extra or plus ions. What are those extra ions? They are OH minus and H plus. Okay, so H plus and OH minus, they will exist from the ionization of H2O molecule. It will dissociate and ionize into H plus and OH minus. Okay, so we have here competition. A competition will be between the ions of the ionic compound and the ions from water. Okay, let's demonstrate some rules in order to predict what are the products of my electrolysis. At the anode, keep in your mind always the higher concentration ion will be formed, or it will win the competition. What's the meaning of that? Assume we are having concentrated solution. It means we have what? We have at the anode, at the first, which type of ions will be attracted to it? The negative ions. Okay, so we have negative ions comes from the ionic compound, and a negative ion comes from what? From the water. It will be what? It will be OH minus. Okay, so OH minus and negative ion, they will fight each other to win the competition. Which one will win the competition? It's the more concentrated ion. Okay, the more concentrated ion. In the case if we are having a concentrated solution, it means we have more concentration of my negative ion of the ionic compound. So the ionic compound, it will do the oxidation. So the negative ion, it's X minus, let's assume it's X minus, it will be oxidized. All of the negative ions, they are ions of nonmetals. So the opposite form, it will be converted into what? A molecule. So this negative ion, it will be converted into a molecule. Okay, that molecule, this reaction is what? We call it oxidation. In order to balance it, we have two atoms here, so I have to multiply this by 2. The charge, it's -2 here, so I have to add 2 electrons in order to have equal charges at both sides. Okay, observation of that reaction, all the time we can say we have bubbles of nonmetal gas or fumes. Okay, in the case if we are having or we are dealing with what? With diluted solution, the negative ions, we have two options, even the negative ion from the ionic compound or the OH minus. When we say diluted solution, it means the concentration of water is more than the solute. Okay, the diluted solution, it's a solution that contains more molecules of solvent over the molecules of solute. Okay, so which one has more concentration, or it has a higher concentration? It's the OH minus. So OH minus, it will do the oxidation reaction in that case. And what's the equation for that reaction? The equation for that reaction, OH minus, it will be oxidized to form what? Oxygen and H2O. Okay, now how can I balance that equation? I will start with balancing oxygen. Here we have 2 oxygens with 1 oxygen, and here we have 1 oxygen. I will multiply this by 2, so I have here 4 oxygen atoms, so I will multiply this OH minus with 4. Now we have 4 hydrogen atoms and 4 hydrogen atoms plus 4 oxygen atoms and 4 oxygen atoms. Stop. We have something else. We have to balance the charges. How can I balance the charge? Here we have 4 times -1, it's -4 charge. Here we have 0 charge and 0 charge. So I need to balance by adding electrons to the more positive side. So I will add 4 electrons here in order to make those 2 sides equal. And the observation of that reaction, it's the formation of oxygen, and oxygen is a colorless gas. Okay, so in the case of aqueous solution, we will separate the 2 cases. At the anode, we have a rule in order to predict which products will be formed on the anode. The higher concentration ion is formed. Okay, in the case of concentrated solution, the more concentrated ion will be the anion from what? From my ionic compound. In the diluted solution, the higher concentration ion is what? Is the hydroxide ion from water. Let's see what will happen at the cathode. At the cathode, all the time, it's negatively charged electrode, and what? The positive ions or the cations will be attracted to it. Okay, what's the rule in order to predict which one will win the competition? Is it the H plus from from H2O, or the positive or the cation from my ionic compound? I have a rule: the less reactive element wins the competition. What's the meaning of that? We have order of reactivity for metals, and it includes what? The hydrogen. We can see here the silver, it's the least reactive metal inside this series. Then after that, more reactive one, it's copper. After that, we have hydrogen, then lead, then iron, zinc, aluminum, magnesium, calcium, sodium, potassium. Okay, so in the case of cathode, you will compare the cation from the ionic compound and the H2. The one that is less reactive, it will win the competition, and it will be what? Reduced. Okay, so at the cathode, less reactive element, and you have to memorize this series in order to compare between the cation and the H plus. And at the anode, you have to compare between, is it diluted or concentrated solution. Okay, now let's take examples, guys. If we have concentrated HCl, what are the formed ions from that solution? Concentrated HCl, it will form H plus and Cl minus, and in the same time it's aqueous. So also H2O, it will form H plus and OH minus. Okay, which one will win the competition? Is it Cl minus or OH minus? We will depend on the rule that at the anode, the one that is higher concentration, it will do the reaction. Concentrated HCl, it means the Cl minus or chloride are more concentrated, so they will be attracted to the anode in order to be what? Oxidized. How can I oxidize Cl minus? It will be converted into Cl2, and I will balance it as usual. Okay, observation of that reaction, I will see after that oxidation bubbles of the green gas. It's the formation for my Cl2. Okay, let's see what will happen here. If we compare the two cations, they are the same, so one of them will do the reduction. So H plus will be attracted to the cathode in order to be reduced. What will happen? H plus will accept 2 electrons in order to produce or form H2 gas, and the observation of that reaction is bubbles of colorless gas. Okay, let's take another example. If the HCl was diluted one, not concentrated, what's the difference? Okay, let's analyze what are the formed anions and cations. From the HCl, we will produce Cl minus and H plus, and from H2O, we will produce H plus and OH minus. Put each ions separated or individually from each other in order to compare or to apply the rule. The rule for anions I will apply: the more concentrated will win the competition. Diluted solution, it means the OH minus is more concentrated, so it will do the reaction at the anode. Okay, the anion, it's all the time it will be attracted to the anode and it will do oxidation. So the OH minus, it will be oxidized to form O2 plus H2O, and I will what? Balance it. I will start balancing oxygen. So this is multiplied by 2. We have 4 oxygens and 4 hydrogens. I will multiply the hydroxide ion with 4, and you have to also, you have to what? You have to balance the electrons. We have here 4 electrons, negative 4 as a charge. Here I have to add 4 electrons. What's the observation of that reaction? I will see bubbles of colorless gas, which is oxygen. Okay. On the other side, hydrogen, it will do the same thing. We can see here both cations, they are the same. So one of them will do the reduction at my cathode. H plus will be attracted to the cathode in order to accept 2 electrons to form H2 gas. Okay. Let's have other example for other electrolyte. We have here diluted NaCl. What are you have to analyze, or you have to put your cations and anions in the case of that electrolyte. NaCl will give me Cl minus and Na plus. Solution, it means we have water. Water, it will form OH minus and H plus. Okay, put the anion on a side, and on the other side put the cation. On the anion part, which one will win the competition? It's the more concentrated one. When we have diluted solution, it means we have more OH minus or more water. So the OH minus will win the competition at the anode in order to be what? In order to be oxidized. So this is the same equation all the time. You have to memorize, guys. The equation for the OH, it's the same. It will not differ. Okay. So what's the observation for that reaction? Bubbles of colorless gas, and this colorless gas, it's what? It's oxygen. How can I test this colorless gas? This colorless gas, we can test it using glowing splint. So I can bring as a splint that is made of wood, and it's glowing one. It means I have lighted and it's about to turn off. So we can put it inside this bubbles, or beside near to my bubbles, so I can see relighting. It will relight. Okay. On the other side, what will happen with sodium and H plus? Which one will win the competition? It's the least. Reactive cation. The hydrogen is less reactive. Let's go back to my series here. If we compare sodium with hydrogen, hydrogen is less reactive, so it will do the reaction. It will do reduction. Okay, so H plus will gain the 2 electrons in order to be converted into H2 gas, and this gas also, it's colorless gas. We can test it using lighted splint. This lighted splint will give me pop sound, like pops, pops. This is the sound you will hear from the lighted splint. Okay. Diluted H2SO4. Let's work out this electrolyte together. I will put my formed ions from H2SO4. H2SO4, when we dissolve it, it will give me SO4 minus and H plus. Okay, we have diluted solution. Also, it means what? We have H plus comes from H2O, and OH minus comes from H2O. Now, which one will win the competition according or related to my anions? It's the more concentrated anion. It's diluted. Diluted, it means the OH minus, it's higher, it's in a higher concentration, so it will win my competition. So OH minus will do the reaction, and you can see it will be the same as this equation. Here we have the same cation, so one of them will be oxidized, or sorry, it will be reduced on my cathode to form what? H2. You have to balance number of atoms, then you balance the charge by adding 2 electrons here. This is my formed gas, and we can test it using lighted splint. Here also it will form what? It will form O2 gas, and we can test it using glowing splint. It will give me real light. It will real light. Thank you for listening, guys, and hope you understand all the points here.